Hello everybody, my name is Claude. I'm a developer advocate at Trilitech. I've been working on Tezos for 4 years already. Today I will give you an overview of the tech stack on Tezos and of what you need to build a decentralized application on Tezos. We're going to see different things here. First, I'm going to make a quick introduction about Tezos, so you have an idea of how Tezos works, how it's different, and why it's better. And after that, we are going to check the tech stack on Tezos, what you need to know to interact with smart contracts and create decentralized applications. Then, we are going to see a little bit more about the languages that we use on Tezos to write smart contracts. After that, I'm going to introduce the most famous library on Tezos to create front-end applications. And to finish, we will have a glimpse into the future of Tezos. To begin, a quick introduction about Tezos. Tezos is an L1 non-EVM blockchain, so we don't use Solidity. The source code of Tezos is written in OCaml. It has also its own smart contract language that's designed for safety and security. So we have a lot of tooling that's pretty different from the rest of the Ethereum ecosystem, but that's designed to be better and safer. The Tezos blockchain went live in September 2018, and I started working on Tezos by the end of 2019, so I was here quite at the beginning. It's been running without any interruption since September 2018, so I think it's good to say that the Tezos blockchain never went down since that time. We use an on-chain smart contract language called Michelson that's Turing complete, and that's designed for formal verification, so you can build whatever application you want on Tezos. We have the language to write complex smart contracts to help you with that. Tezos has no fork. That's one of the benefits of our chain. We upgrade our blockchain every 3 to 6 months with new features. I will show you through this presentation some features that we added to Tezos. And those features were added live to the blockchain where it was running. So it's a bit like changing the motor of your car while you're driving it. There are no forks on Tezos. There is no need to fork the blockchain. And that's an excellent benefit. For example, for DeFi, where you have all your tokens always in the same chain and you don't have to wonder on which chain the tokens are after a fork. That doesn't exist on Tezos. We also have a special consensus mechanism called Tenderbake that's really great because it allows a block finality of 2 blocks. So after 30 seconds on Tezos, every transaction is final and immutable, and that's it. After 30 seconds, you know that all your transactions are included and there will be no more changes. So now a quick overview of the tech stack on Tezos. So everything you need to know to build smart contracts and applications on Tezos. We're going to start with smart contracts. We have 2 main languages to write smart contracts. The first one is called Legolang. There are 2 different syntaxes that you can choose from according to your background. The first one is a JavaScript-like syntax. That's the example you see at the top of the slide. It's a syntax that mimics JavaScript that will be compiled to Michelson before going on chain. But we have that language to make it easier for you to write smart contracts on Tezos. We also have another syntax that's closer to OCaml, so you can pick up the syntax that you prefer. Whatever syntax you pick up is going to be compiled to the same language and go on chain. The second language is called SmartPy. So it's a lot more interesting if you already know Python because it's a Python library. You can get up and running quickly with SmartPy, maybe in 10 minutes, because there are still some concepts about smart contracts that you need to know before you can start writing smart contracts on Tezos using Python. I put here an example of a SmartPy contract. At the top, you have the smart contract, and in the same file, you can write tests for your smart contract. And now a quick example of the language that goes on chain. It's called Michelson. It's a low-level stack-based language. It's designed for formal verification. So it's possible to create software applications that run that code and make sure that it is safe and that it does what it's supposed to do. You can see that there are instructions that you can read, so you can have a quick idea about what the contract does compared to the unreadable bytes Solidity is compiled to, but you don't have to write in that language because you can write Legolang or SmartPy unless you're a nerd like me and you like writing that kind of stuff. It's pretty fun, but you don't have to do it. You can, and actually you should use Lego or SmartPy for your smart contracts. Now let's have a look at front-end applications, because after you write a smart contract, you probably want to write applications for your users to use the smart contract. The main library that you will use on Tezos is called Takedo. It's a TypeScript library that provides all the tools to interact with the Tezos blockchain. So if you know JavaScript, you can use Takedo everywhere you use JavaScript. At the moment, we have a lot of front-end developers, so that's why I talk about front-end, but you can also use it in the back-end. I myself wrote applications with Tauri, so desktop applications for Tezos that use Takedo are possible. So everywhere you use JavaScript, you can use Takedo. Okay, the second library that you would probably use on Tezos is called Beacon. Beacon is a kind of wallet connect for Tezos. It makes the interactions between your application and the wallet easier. Takedo integrates Beacon, so you don't have to play too much with Beacon. But I saw developers who use Beacon outside of Takedo. Beacon is just an NPM library that you can download and use. We have different wallets on Tezos that you can install, and users can choose whatever wallet they like. Beacon is going to handle all the interactions with the different wallets on Tezos on your behalf and in the background, so it's very easy to use. Let's have a look at some tools that you can use for backend applications. We have one that's widely used in the ecosystem called DeepDub. It's a blockchain indexing tool that's written in Python. There are a lot of people who need data from the blockchain, and in general, it can be pretty difficult to get that data from the blockchain. The data updates very quickly, and if you have to write the code yourself, it makes things pretty difficult. We have this tool on Tezos that makes all the hard work for you. You just have to install it and change its parameters, and bam, you have an indexer that indexes the Tezos blockchain. We also have different SDKs and APIs on Tezos that you can use as a developer. The most popular one is called TZKitty. It's an API that you can use to get data from the blockchain. There are a lot of developers who write front-end applications and they use this API to get data from Tezos. For example, on Tezos, you cannot get historic data from the blockchain. You only get data from the current block. So if you want to have access to historic data, you would use something like TZKitty. It's a very good API, it's always running and there's no downtime. You can use it as a REST API or even as a WebSocket API. There are a lot of tools on Tezos that you can use as a developer to create the application that you want. Now, a little bit about tooling. When you are a developer, you want to have access to tools that make your life easier so you can just focus on your use case and not write some code just to get things started. The first tool that we have is called Takeria. If you remember Truffle, that's a similar tool. It's a framework that helps you code on Tezos. It integrates a lot of the tools that I showed you before. So all the smart contract languages, some SDKs, that kind of things into one CLI. You just have to run the Takeria CLI to test your contracts, to test your application, and a lot of other things that you can do with Takeria. The second tool that's very important on Tezos is called FlexTesa. It stands for Flexible Tezos Sandboxes. It's a local sandbox for the Tezos blockchain. You can run a little Tezos blockchain on your own computer and you can test your smart contracts against it. After that, you can test your application against that sandbox. So it makes development very easy because you don't have to deploy your smart contracts on the testnet or another test network. You can deploy them directly in the sandbox that runs on your computer. It's very fast and it's very convenient. We also have another tool that's called Better Call Dev, which is a smart contract explorer. It's a very good tool that I use a lot. It shows you all the transactions that happen in a smart contract. You have access to the storage of the contract, a lot of the data about the senders of the transactions and the amount that was sent, etc. And it provides a lot of data about smart contracts. It's very interesting to use during development. Now that we talked a lot about smart contracts, I just want to show you a few examples so that you have an idea of how smart contracts work on Tezos. I just want to give you an idea of how Tezos is different compared to Solidity. I'm going to focus on Legolang here because, as I told you, SmartPy is a Python library, so it's just Python code. It's pretty easy to pick up. I write contracts in Lego, so I'm going to show you how this one works quickly. Here is the example of the smart contract that we saw earlier, and you can see the different parts of the contract. There is the storage type of the contract. Every smart contract has a type for the storage. There is also a return type for the functions inside the smart contract. You can see that all these functions are going to return the same type, and that's what happens on Tezos. The execution of a smart contract always returns a list of operations and the new storage. And then you have the entry points functions, one that increments the contract, and you can guess by the code what it does. You can see the plus sign. The next one is the decrement function, and the last one just resets the storage to 0. I just wanted to show you a little bit of that code so you can see it doesn't seem too strange compared to the code you're probably used to. Here are some advanced concepts of smart contracts to show you that you can write simple smart contracts, but you can also write more complex ones on Tezos. So for example, you can inline your code in your smart contract and in some conditions to make the output smaller, which is going to reduce the gas cost. Lego also supports dynamic entry points. You can store some of the code in the big map and you can run that code later during the execution of the contract. You can also do inter-contract invocations. Your contract can send transactions to other contracts on chain, and the contracts can talk to each other if they are coded in that way. That's also possible on Tezos. You can also import files into smart contracts. You can split your smart contract in different files, and then you can import them into the main file. A lot of the things that you can do in Solidity are also possible with Lego. Okay, now let's have a look at Takedo. It's a TypeScript library used to write applications. There are multiple things that you can do with Takedo. The first one is that you can read data from Tezos. You can use Takedo to connect to Tezos and read data from the blockchain. For example, you can get blockchain metadata, everything that's in the block hash, the chain ID, that kind of things, you can use Takedo to retrieve it. You can also read account balances when your users connect to your app. You can show their balance in the UI. You can also read contract storages. One of the things that you can do on Tezos that you cannot do on Ethereum is that the storage of a smart contract is public on Tezos. So you can read every value that is in the storage of the contract on Tezos from outside the chain. Takedo helps you with that. It fetches the storage of the contract, and then you can use the values the way you like in your application. Of course, with Takedo, you can also interact with the blockchain. For example, you can send transactions. Takedo helps you format the data that you need to forge a transaction and send it to the network. Takedo also helps you perform different actions that are related to Tezos. For example, you can connect to a wallet using Beacon through Takedo. It takes 2 or 3 lines of code to connect the wallet of your users to your application. And you can also validate values. So if you want to make sure, for example, that the signature is correct, you can use Takedo to verify it. If you want to make sure that the Tezos address is correct, you can use Takedo for that too. You can also encode and decode data. If you need to send bytes to a smart contract, you can use Takedo for that. If the values you get back from a smart contract are in some kind of format that you need to decode for your application, you can also use Takedo. Here are some examples of the code that you can write with Takedo. The first one is how you connect Takedo to the Tezos blockchain. You can see there are only 2 lines of code. You import Takedo from the package, and then you create an instance of the Tezos toolkit where you pass the URL of the RPC node that you want to connect to with your application. It's just 2 lines of code. Here is an example about reading data on Tezos. For example, if you want to get the balance of an account, it's also 2 lines of code. You connect to the Tezos RPC node, and then it's a very simple function call where you pass the address of the user whose balance you want to get. You can also read metadata from the Tezos blockchain. Here, for example, you can get the current block level. It's also 2 lines of code, and you get a JSON blob with a lot of values that you can use later. So Takedo helps you with that kind of things. I was talking earlier about how the storage of a contract is publicly available on the blockchain. Here is an example of how you use Takedo to fetch the storage of a contract. You connect to the Tezos RPC node, you create the pointer to that contract, and there is a very simple function that you need to call to get the storage. In the storage variable, you have all the values that exist inside the storage of this smart contract, and you can use them in the front end, for example, to display them to the users. Here is an example about how to make a test transfer. It's very simple too. You use the address of the recipient, the amount you want to send, and Takedo takes care of everything under the hood. Here is a contract call if you need to send a transaction to a contract. Here we have a transfer entry point on the contract. You don't have to format the parameter you want to pass. It's just a simple JavaScript object. Takedo will format it properly to send it to the Tezos blockchain. And then you just wait for the confirmation. We also have different standards for tokens on Tezos. For example, TZIP12 and TZIP16. Takedo also helps you with that. As seen before, you create a pointer to the contract and then you can get the metadata. For example, let's say that you have an NFT on chain. It's just 1 line of code to get the NFT metadata. You can also get the contract metadata, like the title of the contract or that kind of data, and Takedo helps you with it. Now, Sapling. Sapling is an implementation of ZK snarks on Tezos. It was decided to implement it at the smart contract level and not at the blockchain level. As a developer, you have a choice if you want to use it or not, and Takedo also helps you with that. Here is an example of the code that you could write if you would like to see your balance in the sapling pool. And you see, it's just 12 lines of code to get your balance in the sapling pool in the smart contract. At the beginning of this video, I was saying that the Tezos blockchain upgrades without interruption. Sapling is one of the features that was added live to the blockchain. Events were added to Tezos last year, and it's a new feature that was also added to Tezos without a fork. Takedo also helps you listen to contract events. Here is an example of the kind of code that you could write to listen to contract events. And to finish here, I would like to talk about the future. At the beginning of the year, smart rollups were introduced on Tezos. Now we have rollups on Tezos that are enshrined into the blockchain. They are verified by the protocol to make them safer. At the moment, my colleagues are working on the next rollup called Etherlink. Etherlink is an EVM-compatible rollup. Very soon, there will be an EVM-compatible rollup on Tezos. You will be able to use it to build your applications with Solidity, and at the same time, benefit from the safety and the advantages of using the Tezos blockchain. Thank you for watching. Don't forget to like and subscribe, and I'll see you in the next one.